All right. So today we're doing problem 3137, minimum number of operations to make word k periodic. Okay, so this is definitely one of those problems where it seems more complicated than it actually is, right? I think it would be fair to assume if you read this problem without seeing the classification, like if you were given this problem during an interview, you might assume that it's a hard. And the lesson you should learn from this problem is that you should always assume that there's an easy solution regardless of the information, so that you don't try to convince yourself that the only way to solve this is to do something super difficult. Okay, so sometimes that happens when you solve problems, especially in a high intense, stressful environment like an interview, where you think, oh my gosh, like this problem is so hard. It must be like the hardest thing ever. I must do like a million difficult things, when really the problem just seems more difficult than it actually is, and there's a very simple solution. So take a step back, take a breath, think about the information that you're given, assume there's an easy answer, try to find the easy answer. Maybe it is actually a difficult problem and there is no easy answer. Well, then maybe better luck next time, right? It's really a number game with interviews anyways. Okay, so with that said, let's go ahead and solve this. So you're given a string word of size n and an integer k such that k divides n. Okay, so k divides n. If you're doing a Leetcode medium, you're probably familiar with what that means, but let's just quickly review what that term means so that you're not confused. And this has always been a weird kind of terminology for me, but basically what k divide n means is if k divides n, all that means is that when n is divided by k like this, it's a whole number. Okay, so that means that when 4 divided by 2, n does, so k is 2, n is 4. So does 2 divide n? Yes, because 4 divided by 2 is 2, which is a whole number. Okay, quickly again, so this would be n equals 4, k equals 2. What about n equals 5, k equals 2? Well, that would be 5 divided by 2, which equals 2.5, which is not a whole number. So that means that 2 does not divide 5. Okay, and another way of saying this is if something divides something else, I don't want to get too deep into like the fundamental mathematics of the whole situation. That means that it's a multiple of it, right? So, 2 divides 4 because 4 is a multiple of 2, right? So you go 2, 4, we got it. 2 does not divide 5 because 5 is not a multiple of 2, right? So we go 2, 4, 6. Notice we skipped over 5, so it's not a multiple, so it's not divided, which is why when you divide it, it's not a whole number. All those ideas are, the same way, the different ways of essentially stating the same exact thing. Okay, but just so you understand what this terminology means here. Okay, in one operation, you can pick any two indices I and j. All right, so in this problem, we can select an I and we can select a j. Okay, interesting. So we have a lot of freedom in this problem, which makes you start thinking, oh, this is probably complicated, right? Because I have all these freedom. I can choose an I, I can choose a j. I'm probably going to have to do something n squared. Like, what's going on? That are divisible by k. Okay, so you can only pick indices I and j that are divisible by k. Well, what does that mean? That means if you do I divided by k, or you do j divided by k, they have to be a whole number. Okay, so that's all that basically means, right? So if I choose, if my k is 2, could I do I equals 3? No, because 3 divided by 2 is not a whole number. Could I do I equals 4? Yes, I could, because it's a whole number. If 4 divided by 2 is 2, it's a whole number. Could I do I equals 5? No, I can't. Can I do I equals 6? Yes, I can. Well, what's the rule here, really? I could do multiples of k, right? Because it's I divided by k. If what I'm saying is very roundabout, just review it, review the ideas, think about what it means to divide something, right? But I could do, for k equals 2, I could have I be 0, I could be I be 2, 4, 6, 8, 10, right? Any multiple of k. And that's the same thing for j, right? So there's some sort of restriction on what our I and j values can be because they have to be divisible by k. Okay, so we can't have I and j be anything. They can only be multiples of that k value, which means that they're divisible by that k value. Okay, then replace that are divisible by k. Okay, so we can pick I and j that are divisible by k, and then replace the substring of length k starting at I with the substring of length k starting at j. All right, so that makes it seem really, more complicated, but it's only things of length k. Okay. So what that basically means, if you have a string like A, B, 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 and you had put this like this. Why are you doing this? Okay. We'll move this over here. Now what I'm basically saying is, okay, if you had, k equals 4. K equals 4. All right. So what I values could I choose? I and j values? Well, they have to be multiples of 4, right? So I could choose anything that divides 4. So if we're talking about indices here, right? So we'll draw the indices out so it's a little clearer. So we have 0, 1, 2, 3, 4, 5, 6, 7. Just making a random example to prove a point about how this problem works. Okay. Is 1 divisible by 4? No. Is 0 divisible by 4? Yes, it is. Is 1 divisible by 4? No, it isn't. Is 2 divisible by 4? No. 3 is divisible by 4? No. Is 4 divisible by 4? Yes, it is. Is 5 divisible by 4? No. Is 6 divisible by 4? No. Is 7 divisible by 4? No. 8 would be, and then, this pattern would increase. So that means that our only spots for i's and j's, I guess, in this particular example I just made up, would be here and here. All right? And the thing that I have to replace, so it says I could choose an I and j that are divisible by k, so that's these two green values here, those two indices. Then replace the substring of length k starting at I with a substring of length k starting at j. Okay, so I could take, if I made this my I and this my j, I could take this substring of length 4, of length k, and replace this substring of length 4. So I'm basically taking these 4 b's, right, of length k starting at j, and just pasting them over whatever was at I before, right? So now I paste these 4 b's over. So I'm essentially taking these. They stay in the same spot, but I'm also going to copy them over where those a's were before, right? So if what I did was a little confusing, what I essentially did is I took those b's, I copied them, and I pasted them right over where that I was, right? So I know where to paste them because it has to be of length k, and I paste them over the I over here of length k. So then they all become b's. And so weird operations you can do. It's hard to establish kind of like a recurrence relationship if you want to do dynamic programming, because what would be, I could paste over here, I could paste over here. There's no limits on what I and j can be. They just have to be divisible by k. So it feels very complicated, right? Okay. Now, so basically it's just saying, you're replacing the whole substring from the whole range, right? Which is what I did over here, right? I took b, I took this j, took this I, length 4. I took the 4 digits, the 4 characters, pasted them right over where the I was. And now it becomes this. Okay, return the minimum number of operations to make the word k periodic. So it's like, okay, now there's another idea. What does that mean? Right, so a word is k periodic if there is some string s of length k such that the word can be obtained by concatenating s an arbitrary number of times. For example, the word AB is k periodic for s equals AB. Why? Because the idea here is, always try to write things down. It can help you understand, right? So AB, AB, AB. Well, you'll notice that it's just this pattern AB repeating, right? So it's k periodic for AB. AB repeats, repeats, repeats. Okay, so let's look at this Leetcode example. So we're trying to make it k periodic. So this would be for k equals 2. All right, we have a k equals 4 example, which is familiar to what we just dealt with. Okay, so we have Leetcode Leet. And we have k equals 4. Now the first thing I'm going to do is, well, we're trying to make this 4 length periodic. So that means that whatever's first, it's the first thing, then the first thing again, then the first thing again of length 4. So we take the first thing of length 4, and we just repeat that over and over and over again. Okay? Now, obviously this isn't it's not periodic because it's, Leet, and then it's code, then it's Leet. So that's an issue. I guess one way you could look at this problem, right, is, well, let's first, do what we did here and try to figure out, where could we even put i's and j's anyway? Well, you can only put them on things that are divisible by 4, right? So you could do it here, 0, 1, 2, 3, 0, 1, 2, 4, here. All right, so those are the 3 places where you could actually make exchanges, right? And every exchange you make is going to be of length 4. Okay. So what I'm doing here with the purple thing is I'm saying I can copy any of these pieces any other place. Right, but they're segmented, right? I can never make a copy that's halfway in between these two things, right? There's only segments that I can copy, right? And each of these segments that I copy get pasted over, and it covers the whole entire segment, okay? That idea is going to make this problem much simpler in a moment, all right? But whatever these segments are, well, what is the answer? Well, you'll notice already I have leet and leet. I have a segment leet and a segment leet. So I might as well just take one of the leets and copy it over to code, right? So I'll take one of the leets. So basically I'm taking my I value here, and I'm putting my j value here, and I'm just going to copy the leet over the code. But I'm going to do that operation, so I'm going to have leet, leet, leet. And now for size 4, right, we have a 4 periodic. Leet, leet, leet. So it's 4 periodic. So how many operations did that take to do? Well, we just did that operation one time. This one's a little bit more complicated, so let's take a look at that. And I think with this second example, it's a better example to try to understand what does a solution actually look like, okay? Because it does seem very complicated, right? So we have leet, coolet. So we have leet, C-O-L-E-E-T. All right, now our K value is 2 here. So what does that mean again? Well, remember, I can only, let's write down all of the indices actually. So indices 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And remember, we can only divide things that are divisible by K, right? So we can only put I in J in places where it's divisible by K. So what are those places? Well, we could put it here. We could put it here, 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 or here. Okay. And remember, again, when we do a replacement, it has to be of length K, right? So if I decide that J's here, what is going to end up getting moved to wherever I is? That's what J is of length K. And length of K is 2. So that's where I'm going to put these things here. So this is a segment. If you replaced it, if you put J here, that's what would get, copied and pasted over. If you put I here, that's what would get copied over to I, right? And cool and eat and leet, these are all individual segments. And the idea, again, is there's no like crossing these barriers, right? These are like individual things, and no matter how many times you copy things over back and forth, they'll always stay in these segments. Okay, so that means that there's some sort of independent nature to each of these things by themselves, right? You'll never have a situation where like you try to get a letter over here and a letter over here, and then you try to cut them in the middle, because you can't, because they're individual segments. All right, now the answer is 3. Why is the answer 3 here? Well, there's 2 ways of actually doing it, right? You'll notice that we have 2 lees and we have 2 eats, right? So if I wanted to minimize the number of operations I should do here, well, I already have 2 lees, so I could copy 3 lees over, right? This LE, I could put an LE here, an LE here, and an LE here, and I would get lee, 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 lee. Or I could do ET, right? Because there's 2 ETs. I could copy an ET at the beginning, an ET here, and an ET here. That's 3 ETs. And it'll be eat, 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 eat. That's all I do every day. I've been gaining a lot of weight, okay? And I guess they decided to go that direction in this problem, right? So I'll do it exactly how they did it. So I 0, J equals 2. J is here. So then they end up copying the eat over here. And then I's 4, J's 0. So then they use when this is eat. But I'm not going to walk through the whole thing. But it takes 3 operations, right? And why does it take 3 operations? Because there's 2 eats. There's 3 other things. And we need to copy those things over. And notice there's no like in between. So it actually simplifies the problem a lot. So what the real simplification here is, well, since these things are like independent, and what I mean by that is they're segments that when they get copied over, they stay segments. And they're also the size of the segment is the periodicity that you need, right? So if K is 2, we copy 2, it has to be divisible by 2. Then if eat is something, that could be the K periodic thing. All of these things are a part of that K periodic structure. So what that basically means is at the end, all of these segments need to be the same, okay? So they're independent segments. That's the first thing I would say. So let's start there. And then I guess before I forget what I was saying, all the segments need to be the same. Okay, let's focus on this first point here. Independent segments. What does that mean for this problem? Well, since they're independent segments, the letters within them don't matter. Only their uniqueness matters, what the values represent. Okay? And the reason why I'm saying that is let's think about this problem in different terms and understand that we can think about it in those terms because these are independent segments. There's no crossing over these things. This is a unique ET, right? If I copy LE over here, it becomes LE, but I would never get like CT over here or LT, right? ET will become one of these other segments, but it will never come like a combination of different segments, including itself, right? It's an independent thing all by itself. So when we think about this problem, we could say, well, why don't we call A equals LE? All right, you'll see what I'm doing here in a moment. Let's say that B equals ET. And is that CO? And let's say that C equals CO. So this problem actually becomes A star, A prime, I guess. ET is B star. CO is C star. LE is A star. ET is B star. So notice that I've just described this problem as a different thing completely, and it still works out. Right? Now the game is, all right, I have this A thing. I have an A, a B, a CA, and a B. And remember what the answer was, well, since all the segments need to be the same in the end, that means that I need this pattern to be A at the end, B at the end, or C at the end. Right? Because the K periodicity is the length of each of these things. Right? So the K periodicity is this one thing. So then this one thing needs to repeat over and over again. Right? When we look at here, if I call A leet, then it's AA, and then code could be B. What's the periodicity? Well, the periodicity is 4. 4 is the thing that I'm replacing, so I'm replacing these things independently so I can make it AAA at the end, and then I would only have to use one operation to do that. Here, I have ABC, AB, so I could replace these three with, I could replace BCB with A, so that'll take 3 operations, or I could replace ACA with B, that would take 3 operations, or in the worst, I'm not going to do this because it's not optimal, I could replace AB and AB with C, would take 4 operations. Okay? But since these are independent things, I can treat them as, I don't care what's inside of, I care about what's inside of them to determine what's unique, right? But I don't need to think about crossing patterns because they're independent. And since it's the length of the thing that I can change, the segment is the length of the K periodicity, all I need in the end is to think about it in these terms and then figure out which character, right, which one of these characters, which is a composite of other characters that are unique in a segment, do I need to paint over the end. Right? I can make all these things A at the end, I can make them all B at the end, I can make them all C at the end, I can make them all something different, I can make them all D, no, I can't, because I can only change based on what's already in the system, right? So I can choose any one of these segments and paint it over in the end, and it just becomes a question of what's the best one to paint over, right? So since they're individual segments, K periodicity, so since they're independent, that gives us the ability to draw them like this as just individual characters that are composites of things, because you can never get a part of A and a part of B together, right? They're always independent. All the segments need to be the same. Since the length of the segments are the length of K, then the segment itself is what you need to be the same at the end. So then you just need to copy paste the best segment. Right? So in this idea, I can either make them all A at the end, I can make them all B at the end, I can make them all C at the end, because they're independent segments. And the reason why that's all based is because I can only choose I and J based on the K value. The length of the thing that I'm copying pasting are the K value, so it matches up with the next segment, right? It's the length of it is to the next segment, and then it has to be K periodic, so then it's attached to the segment. Meaning that since everything's based on K here, you get this weird situation where you can draw the problem like this, and then it just becomes an idea of trying to, copy and paste one of these values to make it optimal. So then which value would be the optimal one to paint? Well, the reason why A, let's say that this was D, a different value, whatever that is. What would be the best one to paint here? A. Why? Because A is there already the most. right? So that it would require the least amount of additional operations to make it periodic. Okay, so paste whatever's there the most already. And that's all you got to do to make this work. Right? So when we look at Leetcode here, right, I look at each so basically the way you solve this problem is you say, okay, how many times have I seen Leet? I've seen it once. How many times have I seen ET? I've seen it once. How many times have I seen CO? I've seen it once, right? Those are my individual like segment components. How many times have I seen LE? Oh, now I've seen it twice. How many times have I seen ET? Oh, I've seen it twice. So then what should I paint over? Well, I have two candidates here. There's two ones that I've seen the most. But okay, I'll just paint LE over. Well, how many segments are there? Well, that's just the length of the string divided by K, right? Because that's how many segments we're going to get. Right here, the length is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we get 5 segments. So 10 divided by 2 is 5. So I have 5 things I'm going to have to repaint. But wait, I already have 2 that are LE. So I subtract out the 2 that are already LE. So basically this problem is look at each of the segments, to make a dictionary and account for each of the segments and how much they exist. Whichever segment is there the most, then you don't have to repaint those values. Because I can always just keep using, right? Like here, for example, I can always use this as J. And then I can say, okay, this is I and paint this LE. This is I, paint this LE. This is I and paint this LE. Right? So it's not hard to do it this way, right? There's always a way to make that work. I just keep the J on the thing I want to keep copy and pasting, and then I just go to each I value that I need to change, right? So there's no problem there. So really, how many times do I have to do that? Well, there's 5 segments that need to be painted, right? There's 5 components here, these segments that need to be painted a color, right? So I pick the one that already occurs the most, like I, and then I just go to the other ones that aren't I and paint them over. So I go here and make this J to make this A. I go here and make this J. Or no, J goes to I or I goes to J. I don't remember. But whichever one gets pasted to the other one, this becomes A and this becomes A. So there's 5 in total, right? In this example, there's 5 in total. And there's 2 that have already been painted. So that's the length of the thing divided by K. That's the number of segments. Minus how much the max thing has occurred. And that's pretty much it. So with that said, let's go ahead and get right into it and solve this problem. It's going to take way too much time. So let's do something of occurrence of the segments. That'll be a default dict, lambda 0. So this will tell you how many times each segment occurred. Let's collect all the segments. So that's pretty easy, right? So we'll look at each segment S, the starting point, in range length of word. So we'll start at 0 and go length of word. But like within our problem, right? Like within our problem, the segments start at, 0, then 2, then 4, then 6, then 8, right? Because they have to be multiples because they have to be divisible. So we'll go the range of K, and then each time we'll just increase that word's segment. So what's the segment value? Well, that would be the word at the substring starting at the segment value all the way to the segment value plus K, right? That's the size of the segment that we're creating. And we'll just increase that by 1. And then at the end of the game, we just say, well, how many segments are we going to have to repaint? Well, how many segments are there in total? Well, that's the length of word divided by K. And it's always divisible, so we can do floor divide. Won't lose any information. Minus, well, what's the maximum thing that we've seen, right? What's the max occurrence of any segment, right? Whatever the max occurrence is, we'll use that value to paint the rest, and that'll minimize the number of paintings that we have to do. So that's the values within S. I feel like I'm forgetting something. This should be like that. All right. Now you might feel inclined to say the runtime here is a little weird. Okay, so for time and for space. Okay. For time, we look at all the segments, and then you might say, okay, we look at all characters, and then we have to do K operations to like look at all the characters. So is this N times K, right? Where N is the length of word. It's not, right? The value here is actually N because we jump k spaces every time, and then in between, we count all the characters inside to look at the operation, right? So here, what you're basically doing is, if you have k equals 4, this is dead, so I'm going to quit on that. So you have k equals 4, right? You jump 4 every time, but you look at the k values in between in order to, all right, k equals 4, right? So 0, 1, 2, 3, 4. You do 0, you count all the letters in between to make your segment, and then you jump to the next thing, right? And then when you're at the next thing, so let's imagine we continue this, you count all the k things in between, then you jump at the next thing. So you actually only count everything once. So even though you have k values here, since you're jumping by k, this is actually only n. Here's length of words constant minus the max of here where there's k segments. So I guess it's k time to find the max segment, but k is less than or equal to n, so it's scaled by n. So it's O of n time. And then for space, well, you have to keep track of every letter, right, of every segment, and then put that in a dictionary. So at the end, this will only be at most, it's proportional to the input n. So O of n, O of n. All right, guys, that's it for today. I'm a little rusty. It's been a long time since I made a video, but I'm trying to get back into it. So later.